All right, so one handy thing I gave you guys was this review of reactions that was located in the end of the chapter in your Klein textbook. We covered 15 different reactions this chapter. I know it's a lot, but the mechanisms, I'm sure, as you guys could tell, repeated themselves quite a bit. So if you understand how to make an acetal, you understand how to make a hydrate, you know how to make cyclic thioacetals, make sure you know how to do imines and enamines. Then we also had a few different ones, like reaction 5 on the bottom. That's the Wolff-Kishner reduction. We talked about reductions already in previous chapters, and then we covered a few carbon bond-forming reactions. So what we'll do today is kind of break these down a little bit, and then use these for our synthesis activity. So there's a few important things to do when you're planning a synthesis. All right, the first thing to address is, did the carbon skeleton change? That's a really important thing to look at when you're planning a synthesis. Is typically carbon-carbon bonds are the most difficult bonds to make, so those are the first bonds you want to address. And then the second step is ask yourself, did the functional groups change? Did I spell skeleton wrong? Skeleton. All right, skeleton. Is that spelled right now? All right. Sometimes I get embarrassed that I put this on the internet, but bear with me. All right, now let's do the carbon backbone changes. All right, so for carbon backbone changes, which was question 1 on there, we've got a few different routes. Specifically, we've got CC bond forming. So if we think back to this chapter, we learned or reviewed a handful of them. So I'll start with the generic ketone. The first one that we reviewed involved a treatment with a Grignard reagent. So we can create a new carbon-carbon bond by treating an aldehyde or ketone with a Grignard reagent. And we can form a secondary or a tertiary alcohol this way. The second one we saw was the dangerous one with potassium cyanide and cyanide. And when we do this reaction, what's our product called? Does anybody remember? It's got cyano in the name. Cyanohydrin. So we'll cover a lot of cyanohydrin derivatives next chapter when we cover carboxylic acids, but it's an important carbon-carbon bond forming reaction. The last carbon-carbon bond forming reaction we talked about is using this reagent, which is our ylide. And what's this reaction called? A Wittig, not a Wittig. And when we do this, we can install a new carbon. So these were all the carbon-carbon bond-forming reactions that we reviewed this term. We did cover a couple carbon-carbon bond breaking reactions that are also very important synthetic tools. So let's make a list of CC bond breaking. All right, so again, we're going to just start with our generic ketone, and I'm going to label these as R groups. And we've got 3 different pathways. We'll have a quiz and see who remembers them. So in this case, we're going to break. Oops, this is CO bond breaking, sorry. How do we get rid of that CO bond?
We can attach them up on the bottom and then pop it up. We can use NH2.
Yeah, so one of them was, the first step was hydrazine. So if we do that, followed by catalytic acid and removal of water. And then in the second step, we do sodium hydroxide.
Don't you do the acid first, so protonate the oxygen, and then...
So step one is all one pot, right? You're going to have catalytic acid, you're going to have your hydrazine, and you're going to remove water. So you form your hydrazone. And then the second step is a specific named reaction. Who remembers what that one is?
Ozonolysis?
It's not ozonolysis.
Something reduction.
It's Wolff-Kishner reduction. So in this one, you can break a CO double bond. I should even specify CO double bond. All right, second one is very similar.
You have the sulfur?
Exactly. So we can form a cyclic thioacetal. Add acid and remove water. What reagent would we need in the second step? Yeah, Raney nickel, which is that nickel aluminum alloy that has hydrogen absorbed. All right, does anybody remember the third one for CO bond breaking? It was from last chapter. It was another reduction reaction. Clemmensen reduction, yeah. So Clemmensen reduction, we need a mercury amalgam of zinc, followed by hydrochloric acid and heat. And so all of these are reducing reactions. One thing I will say is with this one is it only works well when R is a benzene, or when R is aromatic. So I'll say when R equals aryl. All right, this chapter we also had a carbon-carbon bond breaking reaction, so let's cover that one really quick. And this one's kind of a non-traditional one. What was this reaction called? We just went over it yesterday. Bayer-Villiger. And what reagent do we need? A peroxy acid. So RCO3H. And that will have the alkyl migration. We said that hydrogens like to migrate, tertiary positions like to migrate, and then after that it goes secondary and phenyl groups. Primary groups don't like to migrate if there's a better option available. All right. So now let's go back to our list. These are all our main backbone changes, specifically carbon-carbon bond making or breaking and CO double bond breaking. Next one is, did the functional groups change? And we're going to go through kind of an abstract list. And I like this one because it reviews a lot of chemistry. So do we know of a way to go from a primary alcohol to an aldehyde? Yeah, we do. It's PCC. What about from an aldehyde back to the alcohol? Yeah, we can use LAH or sodium borohydride. So we know how to interconvert between these two functional groups. All right, now let's add a separate functional group on there, where X equals a halogen. Do we know how to get from an alcohol to a halogen? Or thionyl chloride. What if we want to go in the reverse direction? Yeah, just add sodium hydroxide. So we can convert between an alkyl halide to an alcohol to an aldehyde. Pretty easy. All right, now let's add in one right above. We're going to have our alkane. Can we go from an alkane to a haloalkane? Mm-hmm. So we could do something like Br2 and HV, right? So radical halogenation. What about to an alkene? So the first step would be Br2 and HV, right? And then what would our second step be? Yeah, bulky base, maybe something like tert butoxide. So we can convert between an alkane to an alkene. What if we want to go from an alkene to an alkane? Yeah, just reduction, so hydrogen gas and like platinum or palladium. All right, we'll continue on. I know a lot of this is review that's maybe a little rusty, which is why I wanted to hit it before our synthesis set. How can we go from our alkene to our alkyne? Not quite. We first have to install leaving groups. So Br2. And then we do NaNH2. Yep. I'll add in 2EQ. All right, what about going from an alkyne to an alkene?
Sodium, metal, and H3.
Yep, either sodium and ammonia or Lindlers. Okay, so we've made a lot of progress there. How can we get from an alkene to an alcohol? Yep.
Why are there two equivalents of the NaH2? Wouldn't that be
That's a good question. So if we have our alkene, first step is we put 2 bromines on it, and then we have to do 2 eliminations to get to our alkyne. So you have to have at least 2 equivalents of sodium amide in order to get there. Yeah. How can we get from our alkene to our alcohol? Yeah, you could just do acid catalyzed hydration, so dilute H3O plus. We could also do anti-Markovnikov addition, depending on our situation, so we could do hydroboration oxidation. What if we want to go from our alcohol to our alkene? You could do concentrated acid. Sometimes doing these thought maps is very helpful for reviewing.
Yeah, I just don't have, I wasn't planning, I don't have room.
It's okay. I would try to practice this at home. All right, now we're missing another important reaction. How can we go from our alkyne to our aldehyde? 9 BBN. And NaOH. So we've got a boatload of reactions that we've learned. This is just a sampling of what we've learned. This is not exhaustive by any means. The key thing that we've learned this chapter is we already knew all of these. But now we've got a bunch of tools, specifically 15 new tools to branch off from this direction of our thought map. And that's where the chart I gave you comes into play. It's just one little corner of your toolbox, and we've expanded on it pretty dramatically so far. So I would recommend trying to practice a bunch, make sure you're fairly familiar with the older reactions, and then also make sure that you're familiar with spectroscopy too, because we're not going to spend time on spectroscopy. We're going to focus primarily on synthesis problems. So in the front, there's some synthesis activity sheets. and some mechanism problems. So what we can do is work in small groups and try to plan our way through these. And there should be at least one reaction from this quarter and potentially some reactions from previous quarters. So you've got to start digging into your toolbox of reactions there. Are you guys moving tables? Okay. You guys can, in fact, you're encouraged to push tables together. I think when you talk it out, it's a lot easier than trying to dig through your own personal memory bank.